Welcome back to the Magic of Metadata. As you know, metadata describes other data, giving it meaning, context, and power. And if you want strong foundations, smarter systems, and to be truly AI ready, it starts with understanding your metadata. So let's get into the magic.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness future proof.
Metadata is the data that describes other data. It's descriptive of data. There are many different kinds. There's technical metadata, there's business metadata, but the key, as one of our guests will talk about, is semantics, is meaning. So we're hearing a lot about artificial intelligence these days. Gen AI, of course, has taken the world by absolute storm, which is fascinating, and it's really powerful stuff, but it does make mistakes. It does hallucinate. So in areas or topics that have not been fed into the model in significant amounts, it's just going to kind of make stuff up. Well, that's not good when you're making decisions for your business. You don't want to have hallucinations when you're deciding which product to invest in or which area to build your next store in. So you need to have some grounding to that. And that's why you see so much effort on getting AI ready. That's the term that people are using, AI ready. What does that mean? Well, it means really having an understanding of what data you have. In very large organizations, there is so much data. There are so many systems. We're talking hundreds of applications, scores of databases everywhere, not very cohesively strung together either. Now, there is a technology coming around that's really coming to the fore these days called graph. And we'll talk about graph and what a semantic graph means for metadata and how that can help your organizations. In the chemistry world, they talk about a step change, which is not just an evolutionary change. It's not some incremental improvements. It is a very significant improvement that fundamentally changes how things get done. That's what we're looking at in this example, right, Mark, where you can have that power of metadata fused with large language models to really get to the bottom of what's happening in your business, saving time, effort, and getting you the analysis you need very quickly. What do you think about all that, Mark?
Yeah, that's definitely a big change. I think that the other part of that change is also what we consider to be metadata.
Hmm.
Historically, we considered it the definitions of columns and fields and tables and sources, or the definitions of metrics. This is how this metric's calculated, and you know, cost of goods sold is these costs and this part of sales, but not these, and refining those things. But even when you had words like that, definitions like that, it was never quite enough because eventually you're a big corporation. COGS means different things in different business units and different divisions. Um, you may have a nuanced version for a local team because there's something very specific you're analyzing.
Right,
Does it include shipping costs or not? And if it doesn't, what do you call it?
right.
Because people, when they're in conversation in a meeting trying to figure out what to do in the supply chain, aren't going to string together 15 adjectives in front of this metric. They're just going to say COGS and assume, based on the context of the meeting, you know what you're talking about.
Right.
And yet that information is useful. And if it escapes that group or gets used elsewhere, that's where we end up with all this confusion. And a lot of that information, whether it's, well, interestingly enough now, audio or text, can be attached to these things to make the system more aware of meaning. And when the
Yeah.
system is more aware of meaning, it can meet the human closer to where they are. And for me,
Right.
that's the big thing because these AIs don't do stuff for you. In fact, they suck at doing that. But using them to build the features or to build interface affordances so that they do a better job of making the system work for the people. That to me is where the real strength is going to be. And what we were just talking about here is using some of that to help you with ferreting those things out. Which of these things do you mean? In the old metadata systems, it was, or BI systems even, it's click on this one, look at it. Click on this one, look at it. Click on this one, look at it. No, that's no good. But when you have a conversational AI and you have a piece that is a text interface and you have your data interface that's showing you things side by side, and you can go in and say, no, what I mean is the one that the cost of goods sold that includes shipping costs. And then it can bring up the two or three that actually mean that you can look
Mhm.
at. Search refinement is a lost art. We gave up on it 15 years ago because Google wanted to optimize ads and, throw us more ad slop.
Oh
So,
my
so yeah, I
goodness.
mean, that's the exciting or interesting bits of throwing elements of language and
Wow.
semantics into what was formerly a technical realm.
Wow. And we've also got Suresh Srinivas and Harsha Chintalapani on the show as well. They are co-founders of Collate. They were involved with a company called Hortonworks, co-founders with Hortonworks years ago, which was a real pioneer in open source technology. Now, you've heard on the show many, many times how much we lobby in favor of open source. Open source is the rising tide that lifts all boats. It's very powerful because it allows individual companies to focus on their niche. You have a standard that's set. If you think about standards like HTTP is a standard. That's why we have the internet. We can all share information because of a standard. You have a standard in data analytics called SQL, structured query language. It is a standard. It's accepted by developers. It's accepted by software companies. It's understood by users. And as such, it's like a language that we can communicate with. And Suresh, I want to throw this over to you. What I find so fascinating, and I told a story for our webinar earlier. 24 years ago, I said to a client of mine who was talking about his software's metadata layer, I said, wouldn't it be great if we had a standard metadata layer that all companies adhered to at least to some degree, because then we could share data across domains, across even country lines to really understand the bigger picture of what's going on. And you folks, of course, have done that. There's a project to open metadata. It's an open source project. It has thousands of contributors. It has tremendous traction. And that's the foundation of Collate, right? So, real quick, Suresh, tell us about open metadata as a project and what inspired you and what you mean by all this metadata stuff.
Yeah, so I have seen so many metadata systems that have been built. I myself have built three of them, right? And every company is building their own. And when we started the Open Metadata project, we realized that there are a couple of things that we through our journey in data had understood, which is whenever you're building a metadata system, it ends up being a lot of key value pairs thrown together that nobody understands, right? So, and then it becomes like the structured data problem where you have to document each of those, key value pairs, the key names and stuff like that that nobody does. And metadata becomes very hard to use, right? So when we were working at Uber, right, I'll give you this example. When I joined Uber, people were saying the data is very hard to use. And I was like, why is it hard to use? And we had this microservices architecture, well, like 3,000 microservices and 2,500 engineers. So more than one microservice per engineer so that everybody is happy. But what ended up happening is these microservices also have their own APIs and they produce data, right, that eventually needs to be, analyzed, right? It is, used in analytics. And when I did some study on that, we had hundreds of definitions of location, right? Hundreds of definitions of point, currency, right? Of course, right? Every microservice has its own definition. And that data starts coming into data lake, right? How do you interpret what location means? Somebody is calling location a point a location. In some microservice, a location would have 7 fields. In another one, it has only 3 fields. So it's, a vocabulary nightmare. And so there, what we ended up doing is we built control vocabulary where common things, the common concepts that we have in the business needs to be standardized, and then everybody should use the same thing, right? Location means this, it has these many fields, these are the constraints, right, associated with the data. That's how I understood the power of data standardization and control vocabularies. So we brought that into open metadata, right? Everything in open metadata is defined through control vocabularies using JSON schema, right? So we are a schema first project. And this JSON schema is not only, consumable by human beings, it is also consumable by machines because the structure is defined. There's a type system, there are entities, relationships, sort of, building an ontology for metadata, right? So that's the approach that we took. And since many of the metadata projects were completely, built on non-standard technologies, there was no control vocabulary. We decided we'll build open metadata from the ground up, right? That's how open metadata started with metadata control vocabularies. We have published it as an open standard, right? Now, based on my experience, metadata should be a solved problem now, and the innovation that is built on top of metadata is where we should be focusing. We are not there yet, but that's what we are trying to drive through open metadata.
Well, and it's so important because business dictionaries are not new. They've been around, I mean, arguably for centuries, and you could even possibly argue millennia. We've had definitions of things. But when you start getting into the complexities of a business, especially a large business, there are so many terms that are used. And like Mark was saying, COGS, cost of goods sold. That means one thing to one department, another thing to another department. Doesn't include shipping or not. And these kinds of details, again, if you in the old days, you had a manual, like an actual document you would go read. Well, how many people read the document? Not too many. They get to the index and get to the bit they know and then move on, right? Like it's like the employee manual that's 500 pages. No one reads those things. Nobody at all. I even heard a consultant one time joke that anything past 4 pages, it's understood you're not going to read it, right? To think about this whole what is it, TLDR thing going on, too long, didn't read. It's reality on the ground. But when you can come to these agreements and build the foundation, that's the thing, right? There's a company I talked to a while ago. I love this concept. He said we have a highly opinionated data pipeline, is how he referred to it. And what he was talking about is the fact that 80% of the entities that we talk about in business are the same, and we can kind of all agree on them if we sit down around a table. And the last 20%, that's the hard part, right? The Pareto principle. But because you focus so hard, so heavily and intently for years now, building out the foundation, the 80%, you've really greased the tracks for any number of businesses to sit on top of that and refine it for their purposes, right, Suresh?
Yeah, and business glossaries have been around for a long time, but building a business glossary is not easy, right?
Right.
And I think in the world of AI, right, I think natural language processing has come a long way, right? It's very easy to identify the entities and main concepts and all of that, right? Now, business glossaries were built in every company, right? There is so much of semantic technology that is available, right? That none of these business glossaries map back to, right? Many other
Mm,
concepts. If you look at what
right.
happened in the semantic web world, right? The person, the company, the organization, phone number, many of these things have been defined, right? You don't need to start this work from the scratch, right? You can
Right.
actually rely on so many, linked data ontologies that are available. You can depend on that. That bridge has been missing, right? So everybody starts with what is ARR and stuff like that. And Harsha did not show this to you. What conversational interface provides today with the power of NLP and the context and semantics we are providing to that large language model. What you can do today is you can actually say, "Get me banking terms from the internet," right? So it will get you all the banking terms,
Right.
right? Hundreds of them, and then you can actually say, "Hey, add this to the business glossary in Collect." All of those, get added. You can further refine it. You can further specialize it, but you can build glossaries very easily, right? Second thing is connecting these glossaries to the other concepts, right, that already exists in the standard ontologies, right? That needs to happen, right? You don't need to keep defining person. You can say customer is a person, an employee is a person, right? Uh, all these, connections can be made, and as you make these connections, AI will benefit a lot because it can now reason about the data. It can infer, right? The fact that something is a customer table, something is a employee table, both of them are persons, right? So the personal data can be now inferred, right? Because you can build this kind of relationship, right? And so that's where I see, I'm excited about how the business context will be managed, right? Through, today business terms, business glossary, all the way to ontological terms,
Yeah.
where you bring meaning to things.
It's
Well,
funny,
that's
you
a, I
know,
mean, go ahead.
um, the control. You said, about building glossaries, and yeah, I used to be a analytics director and owned things like that. And then somebody in finance said, "Hey, we're going to do activity-based costing," and this is in manufacturing. And so, activity-based costing, if you don't know what it is just trying to allocate every single possible cost to a product at the ultimate level of detail, but aligned to a process, right? So, if you handle it, stocking your distribution center, and then if you're moving it in your distribution center, and what's the actual storage cost by allocating the amount of space it takes up in your warehouse, and on and on and on. And so you have, you know, tens of different elements. And it took us 3 months of having meetings across the company to come up with that, what is the cost of this product, right? There were 120 attributes of cost. Right. And then of course you have all of these calculations of, well, what do you call the intermediate thing that has the shipping costs, but not the warehousing costs? Or it has the warehousing costs, but not the supply costs. And because somebody, in logistics cares about shipping costs. Why? Because we could ship it on our own. We could do less than load freight shipments. We could ship it via FedEx or UPS, or we could use a third-party service like people on Amazon, shove your stuff, let Amazon deal with the logistics instead of you. So
Right.
it's messy and hard, and it's a people problem.
That's right. And it gets more complex over time. And so the key is to have a foundation, a collaborative medium or marshaling area for these terms that is readily accessible and is machine readable.
What was interesting to me was just that if you think about where we were with computer systems and data, was that everything had to be very precise, sort of, like a library. Every single book has a precise spot on the shelf you want that thing to be, but the reality is how you use things in the context of use. Is this a history book or a science book? Because it's a history of science book. Or do you have to define a new category for it? And we have that obviously tremendously with information because there are so many bits of information in an organization, what we're tracking. And I feel like, the two things that are shifting is that we can tolerate more fuzziness now because we have the ability to find and refine things as we're looking
Oh.
for them. And flipping that around, as Suresh was talking about earlier, we have the ability, to grab some things that are definitions off the internet. And maybe that's a better way of looking at it than the metric we're using. So maybe we want those in there, but I've just thrown 15 things in. The difference, though, is that before it was I would have to figure all that stuff out in advance and get everybody to agree before we put it in. And that's not how we normally work. And the other is that starting from a blank slate is a really hard problem. And having the ability to take something, throw it out there and refine it is a very powerful thing. I mean, what do you think, Suresh?
Yeah, Mark, you were talking about history and science and history of, science, right? So one of the things that I've seen is most of these business concepts were defined as taxonomy, right? And
Yes.
taxonomy has a strict hierarchy, right? That's where ontologies come into play, right? In ontology, you can have multiple parent classes, right? Polymorphism is there, right? So you can connect different concepts, right? And you can have something that connects to history, that connects to science, right? And that connects to maybe chemistry, right? So this kind of relationship can be built using ontologies, and then some of these terms may be your domain specific, right? Within your organization, you may have, within your domain, some additional, customization on top of existing, concepts, right? So I think that's where we are focused on enabling ontologies using, RDF and OWL, right? And we believe that the current way of doing this business terms and glossaries will evolve into connecting to concept, the web of concepts that is already out there, right? And that connectivity is what is super important for AI. Now it can find related data, right? It can the other thing that I also see is in a big way, the structured and unstructured data will be combined together and what will be enabling that is these ontologies, right? The meaning and connecting it from structured data to unstructured data, documents, images, videos, and things like that. So that's one part of things are not what they are. They can be many things, right? And there is fuzziness about it, but there is a way to capture that, right? So,
Hmm.
that's how I think about it. Harsha, do you want to add anything?
Yeah, I mean, in terms of kind of building the semantic graph itself, right? So since we are clear, right, the meaning can't say implicit. It needs to be kind of obvious to everyone. And when we say that, hey, we are building a semantic layer, semantic graph, people often think this is some academic thing, ontologies, theory, lots of kind of upfront modeling and everything else. But in practice, we found it's much more kind of straightforward and simpler and much more grounded in how teams are already kind of work, right? If you take an example of, let's say, supply chain data, right? We may have data sets such as orders, shipments, inventories, and vendors. Structurally, they are all kind of physical tables with IDs and timestamps. But semantically, if you think of an order is a fulfilled by shipment, a shipment draws down inventory, and inventory belongs to a location. So these are not just joins, they are kind of real world relationships. So that's what we enable by modeling them explicitly. There is something really powerful happens. Now the system can tell the difference between a delayed shipment versus a delayed fulfillment. You think of same data, but different meaning, right? So that's where we are coming in and saying that semantic graphs will help you, especially in the world of now, we just showed you with the Osculate, right? That's where the organizations are moving. We all want to take advantage of LLMs to do a lot more things, a lot more quicker. And eventually the agents will take certain decisions. And if you do not model your semantic graph really well, the same data can mean different things, right? If you think of an ordering system that sees an inventory and inventory is low and suddenly kicks off a workflow to order more inventory. But if it doesn't have a meaning baked into that decision, which is why this inventory is low, is it a transition period? Is it a post December sales that tend to have a inventory low? So all of that institutional knowledge now comes into play, telling that, hey, this is the time frame where we historically seen the inventory is low, so do not flag this as and kick off additional inventory. So that's where the power of semantic graph comes into play. It's just not, column is reading from another column. It's about how these things are related to each other in the real world.
Yeah, and Suresh, you said something like metadata solved the visibility problem, but not the meaning challenge. So it's like, okay, I can see this now. That doesn't mean I understand it. And that's what you want with the semantic graph, right? You're facilitating the understanding. Some people call it the literacy, for example, data literacy. Understand what it means in this context. And as we talk about AI agents, we view people view language as a very rich medium for communication, which it is, but that's mostly because we have so much context in our heads from our entire lives. AI agents don't have that much context. They have whatever data they're available to access at that particular point in time. So that's one reason why we're seeing so much emphasis now on semantics again and on ontologies because of this giant strobe light coming down called AI, right, Suresh?
Yeah, so, just going back a little bit, we realize that metadata is super important for solving so many of, the problems with data because it provides context to people to fully understand what their data is. And it also provides context to tools, right? So that you can automate a lot of things, right? That context, unified context is very important. Now, that's how we announced the project Open Metadata, saying we are metadata is at the heart of the problem. And then we are going to build all these workflows, right, such as discovery, observability, governance, things like that, data management workflows. They become a lot easier once you have the context. They are all just workflows that run, right? And the user experience that we provide. Now, fast forward 4 years, there's this model context protocol came in, right? And every data catalog, different kinds of companies that had some metadata started talking about context, right? And this, because of model context protocol just taking off, and everybody became a context system, right? And there is also a lot of talk going on about context graph and stuff like that. To me, context provides you the surrounding information, right? Where the data is and what the structure is and who owns it, that kind of stuff, right? But it doesn't provide meaning, right? The what of the data. It is giving you where, how, that kind of information. But what is the data? What does it mean, right? Now, context was sufficient for people. That's where I was saying it is, we are moving from people-ready data to AI-ready data. Why context is sufficient for people? People stop and ask questions. They go find out somebody, have a hallway conversation, flag somebody else, asking, hey, I don't understand this. Does this mean this, right? But AI is not like that, right? It is very confident. It makes assumptions, fills the gap, and comes up with answers, right? That is why semantics becomes very important, where AI can precisely understand, reason about the data, right? And without that, you're gonna, today we see people, even with people-ready data, right? People making assumptions and creating a lot of data issues. Imagine you unleash AI and then AI fills up all the knowledge gaps and makes assumptions. You're going to have a lot of problem in your hand. So that's where context to semantics is very important if you want your data to be AI ready and you want to use AI with your data.
How you get these actual definitions, and there are any number of ways. I guess my big question is when a company starts using open metadata, you talked about an agentic architecture where you can have agents that start crawling around and looking for things. I mean, this is what the data catalog vendors did that was useful, is scan all your information systems, catalog the different column names, and then make recommendations. Okay, F name is probably first name, L name is probably last name. Can you walk through that beginning process, how you get up and running with open metadata as a foundation for you, and what does that actually look like?
Definitely, we are bringing in all the technical metadata, but also we're bringing in how those tables are being queried, how those dashboards are being used. And along with that, we are bringing in some sample data of that too, understanding how the data is structured. In Fname is the great name for a first name, but most companies doesn't even use that, right? It's a JSON payloads right now. It's going in hugely nested structure. So by looking at the patterns of the data itself, we will be able to recognize what is that particular column means and also classify properly. That's part one. And generating the documentation based on that context, how the lineage is working. For example, maybe a ARR dashboard is using a table called orders. So we will be able to relate to that context and generate a better documentation out of the box. Traditional catalogs never did kind of out of box documentation, so that's been a challenge for itself. And the most important part here is, I think the question comes is, how do we actually enable business terms and business definitions, right? So what we have built there is the ability to kind of bring in your, always in most companies, there is a spreadsheet, there is a Confluence page, there is somewhere some definitions are already built in. We make that really easy to bring into collate our open metadata through our import functionality. Once you have done that, then we have agents that can actually go around and say that, hey, account means this is the account underscore XYZ table, and order means this. And between the business terms itself, we have relations like account has related to an order in this fashion. What is the relation between that? So we're building the relations between the terms. We're building the association with that particular term to the assets itself. So if
Mhm.
you think of the semantic layer is built on top of the physical layer. The physical layer is your technical metadata, your schemas, your column level lineage, and all those relationships. But if you layer on top of the business terms classifications, how they are related to each other, that gives you a semantic knowledge graph on top of it.